Right, today we're approached about assembling a product. So when assembling a product and you're designing your workflow and fixtures, you need to know if the procedure is going to be human operated, is it going to be semi-automated, or is it going to be fully automated with minimum human interaction. So if in case you have a human operator in an operation, you have to leverage the strength of a human versus what a machine can do. So human beings are really good at doing variation. Like if I give you something like IKEA furniture and tell you to assemble it, I mean, for a human being, yes, it might be a nightmare, but you can handle an IKEA furniture. But just imagine telling a how much programming will go into uh, putting an machine together in the middle of your living room with your kids running around and yelling at you. So as you can see, any conditions, we can react to change faster, and that's a good thing. Like I said, your kids and your pets will be running all over your IKEA stuff, but with a automated scenario, that will be the worst thing that OSHA will want to see in the place. So the last step will be the amount of inputs a human being can offer. Just having an operator next to a machine, they offer more value just by being there because they see the changes, they experience the process. Your production engineer can design something and think it's perfect, but throw it on the floor, and over time, people will find a better and shorter way to do it that would actually save the company money. Because everyone finds a shortcut. Human beings are designed to find the shortest, least energy using path is what we are designed to do. So automation is good, especially the industrial revolution came about because we wanted to use machines to increase how much work can be done with a human being. Started with 1 horsepower, using horses and oxen to plow the land, and then the steam engine came, and then we started measuring that output according to horses because that's what we were used to before. And right now, the kinds of stuff you can get from a motor that's just can fit in the palm of your hand to control many axis robots, it's just impressive. So the main thing, when you add automation into your production line or assembly line, it's just there to help the human out. So the main intention of them is to cover our backs and what we're not good at, and that would be we do not like repetition. Human beings get tired of tedium. I mean, that's why they try to get shortcuts. Your worksheet can say this is exactly what you're supposed to do, but trust me, someone will find a way to skip a step or two and still be within tolerance of what you can pass through production. So injecting machines into your line is definitely going to increase your productivity. So in this case, we were approached with somebody who wanted wooden toys, and the wheels and the body of the toy itself is supplied by one vendor, and then the metallic axle and the plastic brackets come from a different vendor. So we have two vendors in this case, and this is exactly what they wish for. This was their wish list. So we designed it out, and with the aim of doing a manual assembly on this part. So we had to come up with fixturing and the best way to guide someone to do this part. So the first step is the block itself. I mean, that's just wood. And the first step, I will walk you through the procedure shortly so you can see exactly how to work with this. But this just shows you this is the final product we want, and those are the steps that are automated in between. So the materials we'll end up using for this process will be the wooden car body from the first vendor, then the metal axles from the next vendor, the wheels, screws, and fasteners from another supplier. So we're already dealing with 3 different people, and we're just getting materials directly from them. Then the equipment will be standard stuff to use in woodwork, and uh, the main case is the station itself, and the station we'll want to optimize it, so we'll have shadow boxes for where the tools go. We'll make sure the screws and the washers, the wheels, the axles are stored right next to the operator to conserve motion economy and promote ergonomics. And then the machine part will be the conveyor feeding the wooden body to the operator, and then that will connect it to the next station, which is headed towards packaging, because after this it should be done and ready to be packaged, and then finally to palletization and then into storage. So the conveyor will be turned on and by the operator and turned off by him, because the process is dependent on how fast the operator can work. We'll make sure that it's clearly labeled with a green for the on and off, and probably want to use foot pedals in this case. That way the operator's hands are free all the time. They can be able to walk faster that way. As I mentioned before, the labeling will be legible and at the operator's eye level to promote better posture, and then there'll be a speed control there next to where he can get to it, just to, if he's walking faster than usual, then we can crank up the speed a little bit. It's up to him, so that way you can have a slow walker come to that station and not suffer, because it was designed for someone else. And then we'll have definitely an emergency stop next to the operator just in case something happens. And then lighting should be good, ventilation should be good, and with COVID, hand sanitizers and extra masks will be next to the station just to make sure it's there when it's needed. So here's a quick look at the flowchart itself. It'll be starting, then the system analyzes, calls for for the parts to come in, the operator walks on it. The final check will check if the wheels are spinning freely, and then goes back and make sure that the product can pass checks. If not, it'll go to the defective box right next to him, and will be collected at the end of the shift. And then if it passes, then it goes into the conveyor to the next stage. So, all right, so let me walk you through the procedures. It will be, the first step will be to initialize the system, and that's by turning on your station. And then you can now use the buttons there. Using your foot pedal, you will be able to call the wooden bodies that will come in with the conveyor. And then you'll pick up that wooden body and place it onto the vise up with the bottom face up. Then tighten it down. Make sure you use cloth or paper on the sides just to avoid the vise marks from coming onto the piece of wood. And then there's a piece of paper over there that you'll just put it on top, and then it has all the markings for where the pilot hole should go. Get your mallet and the chisel and just make some pilot holes all around. And then the next step will be take the 4 brackets off the packets. They should be right next to the station, and then you place them there. Make sure you line the holes up, place it in, and screw it. Put in the screw and fix the screws into all the positions, and then make sure that one's fastened safely. And then go back, take the axle, the first axle, the front axle, put it through. On either side, you can now get the wooden wheels, the first 2 front wheels, put them on either side. Use the other metallic screw with the washer, put it on the wheel. Make sure it's freewheeling, and do the same to the other side. Then you'll go to the back side and do the same, and then you'll be done to quality check. Just make sure everything is lined up, make sure the wheels are free moving, and if there's any defects from the process that you just went through, go ahead and put that in the defect box next to you, and everything else that's good, you can just put it straight into the conveyor and send it down to packaging. you're free to look back to the other videos so you can see exactly how the process goes. Other than that, I wish you all the best and thank you.